All right, so today's functional group, I would say, is possibly one of the most complicated ones we do, just because the arrangement of things gets to be really, really important. Um, so, starting off, just a little bit of review looking at this molecule here. We know that it is 1, 2, 3, 4 carbons. I'll even number them here. 1, 2, 3. Pretend that's a 3 and 4. We have this alcohol group here. We have an aldehyde group here, but they're on the same carbon. And before we learn that if you have both of those on the same carbon, that is a carboxylic acid. All right, and in this case, it doesn't matter which one I have on top, which one off to the side, whether it's the OH or the aldehyde group, the double bonded oxygen. It's still the same thing. Essentially, we can rotate these things around to get it to look like that. And technically, it's kind of the same thing. So to name this, we would call that just butanoic acid. Now, the thing about acids, though, is we know that this hydrogen comes off really easily. So if we remove, that work? There we go. If we remove this oxygen here, that oxygen's not happy anymore. That oxygen still wants another bond. And in some chemical reactions, that'll happen. So before we learned about ethers, which is when we had an oxygen with like 2 carbon chains on either side. In this case, what we're going to be looking at, so down here, these are called esters. Essentially, we still have an oxygen breaking up the chain, but on one of the carbons connected to that oxygen is that double bonded oxygen. So really, so this is an ester as opposed to an ether. So ether, ester, ether, and then carboxylic acid. Really, esters are formed when a carboxylic acid replaces that hydrogen that was here with another carbon group. And we can kind of see that here. Like, if we had an H here, that would have been the end of it, but instead we removed the H, put on these 2 carbons here. To name esters, it's important to keep track of which carbon chain has I guess in this case it'd be more of a ketone, maybe it's still an aldehyde, just as double bonded oxygen. It matters which side it's on. So in this case I have 1, 2, 3, 4 carbons here, so we have F. Over here we have not F, bute. And over here we have 1, 2, so we have an F. Okay. Now, to indicate that this is an ester rather than an ether, if that wasn't there, we would just call this butyl ethyl ether. But in this case, we need a name to represent this double bonded oxygens here. To do so, we're first going to name the carbon chain that does not have the double bonded oxygen on it. In that case, we're going to start with the eth part. So this is ethyl. All right, so now when I name the carbon chain with the aldehyde group on it, I'm just going to start with the bute. All single bonded, so butane, I should say. And then to name these things, we're going to go with something that makes no sense at all. This is ethyl butanoate. We're going to end it with OATE. Ethyl butanoate. That means that the O8 means I have an oxygen with that double bonded oxygen here, the oxygen in the middle of the chain. One side of an ethyl, so 1, 2 for the F. The other side, butane, 1, 2, 3, 4. O8 means that first carbon, away from the oxygen here, gets that double bonded oxygen group there. Now keep in mind, these 2 molecules are not the same thing. We still have eth on one side, but on the other. But in this case, the double bonded oxygen's on the eth side of things. So to name this one, I first name the chain that does not have the double bonded oxygen, so this will be butyl. Then I name the part with the double bonded oxygen, so then eth. Null single bond, ethane. And then just to indicate that this is in fact an ester, that we have this arrangement going on here, I just end it with OATE. Butyl ethanoate. Um, it's easy to kind of confuse these things with ethers because we do have that same oxygen in the middle of the chain. But just keep in mind the difference is that we have this double bonded oxygen right away. So if I scroll down here a bit, one key thing here, doesn't matter how many I have, that double bonded oxygen has to be on this carbon or this carbon. If I have that, that is no longer an ester. For it to be an ester, I would need to have that double bonded oxygen coming off there or there. And keep in mind also these molecules, they can also be, go the other way, where if I go down there, like looking at butyl ethanoate, I could have gone like that. The arrangement, whether you start by going up or going down, that part doesn't matter. What's important though is that we have the oxygen in the middle of the chain, and on one of the carbons on either side of it, we have that double bonded oxygen. No numbers again, because essentially we're just naming each side of the oxygen. We're just naming those chains. All right. If you need help, I'll be around. Otherwise, good luck with the practice.